Hello everyone. Today we are going to discuss few chemistry concepts in our daily life. Why do certain cut fruits and vegetables turn brown in color? The freshly cut fruits like apples, bananas, pears, avocados and vegetables like potatoes turn brown in color due to a chain of biochemical reactions known as enzymatic browning. The enzymes responsible for this browning is polyphenol oxidase, in short PPO, which is also known as tyrosinase. You can see in these pictures, this is freshly cut banana pieces, and this is after enzymatic browning. This is fresh slices of apple, and this is after enzymatic brown. This enzymatic browning easily takes place when the pH is in between 5 and 7 and also at warmer temperatures. The presence of iron or copper cofactor increases the rate of browning, which is evidenced when cutting the fruit with a rusted knife, which increases the rate of browning. If a fruit contains a large amount of PPO enzyme, then browning also occurs more quickly. When a fresh apple is cut, the injured plant tissue is exposed to oxygen in the air. The polyphenols, which are naturally present in the apple's flesh, are oxidized by PPO enzymes. Due to this oxidation reaction, orthoquinones are formed, which in turn polymerizes themselves or they will react with proteins or amino acids to give complex brown colored melanins on the exposed surface of the fruit. We all know that melanin is a primary pigment determining the skin color in human beings. Hence, the damage to cell structures in the fruits and its exposure to oxygen is very essential for this enzymatic browning. Then, how to slow down the browning of fruits? PPO enzyme works best at pH equal to 5 to 7. Rubbing the exposed flesh of the fruits with the lemon juice, which is acidic in nature, may lowers the pH and also inhibits the enzymatic activity. Thereby, you can slow down the browning of fruits. And refrigeration of these fruit slices can also slow down the browning. Enzymatic browning is not always a defect. Sometimes it is also essential as it contributes to the characteristic color and flavor of raisins, tea leaves, and cocoa used in chocolate. You see here for these raisins as well as tea leaves, the browning is very important. Next, we are going to discuss the chemistry in chilies. Why chilies are hot and spicy? A group of compounds called capsaicinoids, which includes capsaicin, dihydrocapsaicin, homocapsaicin, not dihydrocapsaicin, were found in chilies. These are responsible for their distinctive hotness or spiciness. But of all these capsaicinoids, the major compound in chilies producing these hot and spicy effect is capsaicin. You can see the structure of capsaicin from this picture. The capsaicinoids, particularly capsaicin, stimulates the pain and heat sensitive receptors, TRPV1 receptor in particular, deceiving the brain into thinking it's being burned. Most of the people think that the hottest part of the chili is seeds, but actually the hottest part of the chili is the white flesh or pulp that holds the seeds or that houses the seeds. This portion of the chili contains highest concentration of capsaicin. As in the earlier slide, you can observe that chilies have various colors and also different flavors due to the different concentration levels of capsaicin in them. The capsaicin content even changes during the ripening process of these chilies. Next, how to determine the hotness of the chilies. There are two different methods to determine the hotness in the chilies. First method, the Scoville scale proposed by Wilbur Scoville is used to measure the spicy heat of chilies in Scoville heat units, in simple SHU, based on the content of capsaicin in chilies. It is an organoleptic test. That is, this test uses sense organs or simply taste detection based test. He given 16 million SHU for pure capsaicin in his scale. If you go for capsicum, you see in this picture the capsicum, the Scoville scale gives 0 to 100 SHU, and the well-known Guntur chilies shows almost 25,000 to 50,000 SHU. The standard pepper sprays shows 2 million to 3 million SHU in the Scoville scale. And the second method and the most accurate and precise method for determining the heat of different chilies is high performance liquid chromatography HPLC and gas chromatography mass spectrometry GCMS. This method particularly quantifies the amount of capsaicinoid in the chilies. From these pictures, you can see this is HPLC and this is the picture of GCMS spectrometry. Then, how to suppress or quell the hotness of chilies? Capsaicin organic molecule is hydrophobic. That means it does not dissolve in water due to its long hydrocarbon tail. You can see from this picture it has long hydrocarbon tail. Hence it is readily soluble in fats and oils. Then, how to suppress the fire of chilies? The best choice for soothing the burning sensation of chilies is to drink full cream milk, or the other choice is to eat ice creams instead of drinking water. Then, what are the applications of capsaicin? Capsaicin is used in standard pepper sprays and also in repellent sprays to protect garden from mammalian pests. This capsaicin does not affect the birds. Next, we are going to discuss how the mint products produce a cooling effect. Mint oil is used to flavor candies, toothpaste, chewing gum, mouthwash, drinks, etc. Mint contains an organic compound known as menthol, which gives the characteristic aroma, that is smell and flavor, to the mint. This mint is the responsible compound for the cool sensation or fresh breathing feeling produced on consuming these mint products. You can see in the slide different mint based products like candies, mouth fresheners, chewing gums, etc. This menthol is a white waxy crystalline organic compound which melts just above the room temperature. This menthol binds and activates the cold sensitive nerve receptors, in particular TRPMH, and produces the cooling effect when you consume these mint products. In the picture, you can see the structure of the menthol responsible for the cooling effect of mint products. Hence, we can conclude that menthol does not really cool you, but it tricks your tongue or skin feel cooler. Thank you for your patient listening.